Hey everyone, and welcome back to the channel. If you're just starting your journey with Python, you've come to the right place. Today, we're diving into one of the most fundamental and powerful data structures in Python, the list. So, what exactly is a list? Think of a real-world shopping list. It's a collection of items, right? You have milk, eggs, bread, and so on. They are written in a specific order, and you can add new items, cross off existing ones, or even change an item if you decide you want brown bread instead of white. A Python list is almost exactly like that. In technical terms, a list is an ordered and mutable collection of items. Let's break that down. Ordered, this means that the items have a defined order, and that order will not change unless you change it. The first item you add will always be the first item. Mutable, this is a fancy word for changeable. You can add, remove, or change items in the list after it has been created. Lists are incredibly important in Python because they allow you to store multiple pieces of data in a single variable. This helps you keep your code organized and efficient. This is the most common way to create a list. You define its contents right away. The basic structure is list name equals, in brackets, item 1, item 2, item 3. To create a list of numbers, simply place them inside the brackets, separated by commas. For text items, each string must be enclosed in quotes, either single or double quotes. Python lists are flexible and can hold different types of data simultaneously. Often, you'll need to start with an empty list and add items to it later. To do this, just use a pair of empty square brackets. This is useful for collecting items from user input or a loop. You can think of this like starting with an empty shopping cart before you begin adding items. You can also create a list using the built-in list function. This is particularly useful for converting other data types, like a string, into a list.
Okay, so we know what a list is, but why should you care? Lists are fundamental because they help you keep your code clean and organized. Imagine you wanted to store the names of three friends. Without a list, you might do this. This works, but what if you have 100 friends? That's a lot of variables. With a list, you can store them all in a single, neat variable. This makes it much easier to manage your data and perform actions on all the items at once, which is something we'll cover in future videos. Just as we have already seen with strings, you can access elements in a list in a similar manner, using an index which starts from a base of 0. You already know that a string is a sequence of characters. To get a specific character, you use its index in square brackets. A list is a sequence of items. The rule for accessing them is identical to the rule for strings. You use the item's index, starting from 0. The only difference is that instead of pulling out a single character, you pull out the entire item. Let's look at a list of greetings. As you can see, the syntax, list I, and the logic, zero-based indexing, negative indexing, are exactly the same. The only change is that you are retrieving a complete element from the list rather than a single character from a string. Of course, since you're familiar with string slicing, list slicing will be second nature. The concept, syntax, and rules are identical. Slicing is the technique used to get a smaller portion, or a slice, of a sequence. You're not just getting one element, but a whole subsection.
As you know, with a string, you can grab a substring using the start:stop syntax. This gives you all the characters from the start index up to, but not including, the stop index. As you can see, the syntax 1:4 worked identically. It started at index 1, Flask, and collected all items until it reached index 4, which it did not include. All the slicing shortcuts you know from strings work perfectly on lists too. The key takeaway is that if you know how to slice a string, you already know how to slice a list. The only difference is what you get back, a new string or a new list. One of the most powerful features of lists is that they are mutable, which means you can change their contents after they've been created. You can change a single item or even a whole section at once. The second task, read book, is at index 1. Let's change it to go for a run. The item at index 1 has been successfully updated.
You can also change an entire slice of a list at once. This is a powerful way to update, add, or remove multiple elements in a single step. Let's use a list of letters. Now, let's replace the middle section, C and D, with new letters, X and Y. We need to replace the slice from index 2 up to index 4. Interestingly, the new list of items doesn't have to be the same size as the slice you are replacing. You can add new elements to a list in several ways. The three primary methods are .append, .insert, and .extend. The .append method is the most common way to add to a list. It adds a single item to the very end of the list. Think of it as adding a new song to the end of a playlist. Let's start with a list of tasks. Now, let's add a new task, call mom, to the end of the list. If you need to add an item at a specific position other than the end, you use the .insert method. You provide two pieces of information, the index where you want to add the item and the item. This is like carefully placing a new book onto a shelf at a specific spot, causing all the other books to shift over to make space. Let's say we have a guest list. but we forgot to add someone at the beginning. Notice how Bob and Charlie were automatically shifted to the right to make space for Alice. The extend method is used when you want to add all the items from another list or any other iterable, like a string or tuple, to the end of your current list. This is like taking a second shopping list and adding all of its items to the end of your first one. Let's add all the items from second half to the end of first half. This is a common point of confusion. If you use .append to add a list, it adds the entire list as a single nested item. If you use .extend, it adds the individual items. Notice the nested list 4, 5 at the end of the second example. Use .extend when you want to merge two lists. There are several ways to remove elements from a list, depending on whether you want to remove an item by its value, by its position, or clear the list entirely. Use the .remove method when you know the value of the item you want to remove, but not necessarily its index. Important. This method will only remove the first occurrence of the specified value. Notice that only the first cat was removed. If the item doesn't exist, Python will raise a value error. Use the .pop method when you know the index of the item you want to remove. A unique feature of .pop is that it removes and returns the item, so you can save it to another variable if needed.
If you don't provide an index, .pop will remove and return the last item in the list by default. Now let's pop the last item without specifying an index. The del keyword is a more general way to delete things in Python. When used with lists, it can remove an item at a specific index or even remove an entire slice. Unlike .pop, it does not return the removed value. This is where del is especially powerful. You can remove a whole range of items at once. If you want to completely empty a list, the .clear method is the simplest way. It removes all items, leaving you with an empty list. Here are some of the most common and useful operations you can perform with Python lists. The in and not in operators are used to check if a specific item exists within a list. They always return a Boolean value, true or false. Think of it like quickly scanning your shopping list to see if an item is on it. The built-in len function tells you how many items are in a list. You can use the plus operator to combine or concatenate two lists. This creates a new list containing all the elements from the first list, followed by all the elements from the second.
You can use the asterisk operator to create a new list by repeating the elements of an existing list a specified number of times. Think of it like using a rubber stamp to print a pattern multiple times. These functions perform a calculation on a list and return a single value. They work on lists of numbers, while min and max also work on lists of strings using alphabetical order. Min of list returns the smallest item in the list. Max of list returns the largest item in the list. Sum of list returns the sum of all items in the list, works only with numbers. Python offers two ways to sort lists, and they have one crucial difference. The sorted function takes a list as an argument and returns a new sorted list. The original list is left unchanged. This is like making a sorted copy of your document and leaving the original as is. The .sort method is called on the list itself and sorts it in place. This means the original list is permanently modified and the method returns none. This is like directly organizing the files in your folder. The original messy order is gone. You can also sort in descending order with both methods by adding the reverse equals true argument.
And there you have it. You now have a complete understanding of Python lists. You know how to build them, change them, and use all the most important methods. Well done. If you learned something new, I'd really appreciate it if you hit the like button and subscribe to follow along. Thanks again for watching, and see you next time.